All right, let's get right into it. So this is Intro to Linux. First thing I want to mention is that there will be timestamps somewhere on screen right now. And the reason for that is because if you're completely new to Linux, you can watch the whole thing. If you're not, you can skip around the video to whatever interests you and go from there, or whatever you need more practice in. I will say though that I have planned this, and I have demos that I can show you real world examples. It's not just like throwaway examples or code or anything. So if you are interested in that, I would recommend to stick around so you can get more experience and see how these sorts of tools are used in the real world. All right, let's get started. First thing I want to say is that if you're coming from the Discord server, I have probably attached a Docker file to this link. And what this Docker file is it sets up a Linux environment inside your terminal. And the reason you need this is because obviously this is a Linux intro. We're going to be running Linux commands. If you're on Windows, these commands are not going to be working on the command prompt or PowerShell. If you're on Mac, these commands will probably work until we get later on into the operating system section of this introduction or like this video. Yeah, so anyway, if you want to play around with it, all the packages are already pre-installed inside this Docker file, and right now I'm going to show you how to build that environment. You don't have to know anything about Docker or anything. I'm just going to show you these commands. So whatever directory your Docker file is in, you want to run this command. So docker build-t linux intro dot. Mine is going to be faster than yours because I already did this, but once that's done, you want to run docker run-it linux intro. And now you are in the Linux environment. You can verify this because it says student, and it's going to be a random number here. So this is how you know that you're in. If you want to verify 100%, you don't have to know what I'm doing here, but you can do cat etc and os release, and you'll see that the name is Ubuntu. So again, you don't have to understand anything of what I did. You don't have to understand Docker. Just know that if you run these two commands here, docker build and docker run, you will have your Linux environment set up locally, and you can exit it at any time by just typing exit. And now we're back to normal. Right, one more thing I wanted to mention. If you run the docker command and it says docker command not found, it means that you don't have Docker installed on your device. So to do that, you just go to this link right here, docs.docker.com/desktop. So Docker desktop, you scroll down and you can install Docker desktop for whatever you need, Mac, Windows, Linux. I'm on Mac, so you can find all the instructions right here. All right, so now let's talk about why Linux. Well, everything runs on Linux. Everything that in the software world is likely running on Linux. Things like CI/CD pipelines are all of them are running on Linux. I've never heard of anything CI/CD related running on Windows or Apple like Mac OS. IoT devices, so embedded systems, anything that's done in embedded systems is done in Linux because Linux is a lot more lightweight than Mac OS or Windows distributions of operating systems. What else? Cloud platforms, cloud servers are running on Linux. Almost all of them, the grand majority of them are running Linux. Yeah, just basically everything. Containerization services such as, or platforms such as Docker and Kubernetes, anything containerization basically is running on Linux as well, again, because it is super lightweight. So it's very likely that through your career and sometime in college, university, whatever you're doing, internship, you will be using Linux quite extensively at some point. So if you don't know how to debug, how to secure, how to exploit, how to generally just work in Linux, you are likely going to be cooked. So with that, I hope I convinced you, and let's get started. Okay, now before we learn our first command, we're going to talk about the Linux kernel. What is the kernel? Kernel basically you can think of as the operating room of the Linux computer. By that, I just mean that it's where everything is processed. All of the it's the interface between your hardware and the software. So anytime you run a command on a terminal, you're actually just sending the command to the kernel, and the kernel is translating it to whatever needs to be done at the hardware level, basically. There's a lot more to this. There can be a whole like 5 videos, 10 videos on kernels alone. It's a very complicated topic, but the basic is simply that you write commands to the kernel, and then the kernel translates those commands to the hardware that you're running. So with that, let's learn our first command. It's going to be how to list directories. So Linux, just like every other operating system, everything is files. By that, I mean that you are in a directory, you have files in your directory, you can have directories in directories, all these sorts of things. So to list the contents of your current directory, you do ls. This stands for list, and there we go. We just do ls, enter, and then I have 2 files in my current directory. Now, speaking of what is my current directory, or speaking of my current directory, if I want to find out what my current directory is, we can do pwd command, which stands for present working directory. And this will tell me what directory I'm in currently. So if I want the full path of my Docker file, it's going to be whatever my local present working directory is, just like this. This isn't a command, by the way. This is just me showing you that if I wanted to talk about, or if I wanted to point a command to use this Docker file right here, this is the path I would use, okay? I hope that made sense. So now let's talk about file CRUD. CRUD stands for create, read, update, delete. It's more of a database term, but I'm going to use it here as well. So first up, how do we create a file? We create a file using the touch command. So again, let's list everything in my current directory. We only have 2 files, and now we're going to use the touch command to create a new file called test.txt. If we list my files again, you'll notice I have test.txt now, which is what we expected. Awesome. Next up, how do we read a file? How do we read the contents of a file? Well, for that, we use a command called cat. So we can do cat test.txt, just the name of the file that we want to read from. Okay? And we get nothing. This makes sense because we just made the file. So we make the file called test.txt, but we don't put anything inside the file. Okay? So that's why it's empty. For example, if we take this Docker file instead, so we do cat Docker file, we see that we're reading the contents of the Docker file, and this is the contents of the Docker file. Okay? I hope this makes sense. Nothing crazy. We're just reading contents of a file. And now, as you can see, if you have a file that is like super long, this can get pretty out of hand pretty fast. So there are other ways that we can read contents of a file. For example, instead of using cat, which generates the output is the whole file contents, we can use head. So head Docker file. And this is going to print out the top 10 lines of the file. So here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, 10 lines. We can do the same thing, but from the bottom. And we do that using tail. So tail Docker file, and we get the last 10 lines of the file. You'll see here, it's the same thing, right? Last 10 lines of the file. Perfect. We can also specify specifically how many lines we want to see. So for example, we're going to do head, and we're going to pass in something called a flag. A flag is just an option or like a change to the behavior of the command that you're running. So in this case, if we use the -n flag or just the n flag, we can specify the number of lines that we want to print. So in this case, I want the first 3 lines of the Docker file. So if we run this command, you'll see we get 1, 2, 3 lines of the top of the Docker file. Instead, if we do tail again, n3, this time we're going to get the last 3 lines of the Docker file. I hope this makes sense. Perfect. So now we know how to create, we know how to read files using cat, tail, and head. We're going to skip update for now, but what about delete a file? So again, we have our test.txt, and we've just listed it using ls. Okay. To remove a file, we use the rm for remove, and then the name of the file. Okay. So we do this, we list all our files, and there's no more test.txt. One warning about remove. As soon as you remove it, there's no like recycle bin to get it back. So if you accidentally remove something, it's gone forever, basically. So be very careful with remove, because that can be pretty scary. Okay. Next up, we're going to talk about CRUD on directories or folders. Okay. Whenever I say directory, it's the same as a folder, but in Linux they're called directories. Okay. So same thing. We're going to list what we have to make a directory. To create a directory, we use the make directory command. Okay. And then the name of the directory, I'm going to call it Linux intro. Oops. Linux intro. Perfect. So now if we list, we'll see we have a Linux intro directory. Now you might be wondering, how do I know that it's a directory? Well, in my case, I have a specific formatting on my terminal so that all directories are colored blue. Okay, that's why this is blue and these are not, because Linux intro.pem and Dockerfile are files, whereas Linux intro is a directory. In a second, I will show you exactly how to determine that. Actually, I'll show you right now. So we know about flags now, but we've only seen them with head and tail, right? But almost every other command that I know of, at least, supports flags. Okay, so ls supports flags, specifically -l. -l stands for list. Okay, so it'll list the contents of ls like this. So this looks a little scary, but we'll go over this in detail in one of these in this video. So again, we have a Docker file, Linux intro. So it's exactly the same things, except now we get more information. Okay, don't worry about anything here. The only thing I want to point your attention to is that this section here, this has a D in it. The first character is a D. That means that this is a directory. You'll notice that these two do not have a D. Okay? They don't have anything. So those are files. Okay? That's what that means. Again, we'll explain what these are later, but I just wanted to tell you that if it has a D, then it's a directory. Okay, so now we know how to create a directory. What about read the contents of a directory? Well, we've actually already know how to do that, and it's through the ls command. So with ls, we can list the contents of our current directory by default, or we can list the contents of a specific directory. So we can do ls, for example, Linux intro, and it will list all the contents inside the Linux intro directory. Now, there's nothing there right now, and that makes sense because we haven't made any files in there, but we can do that using the touch command, right? So we can touch inside Linux intro, we're going to make a file called linux intro.txt. Okay? And now if we ls inside Linux intro, we'll see that we do have the file we just made. Okay, so that is ls, and we can do the same thing here, ls-l Linux intro, and you'll see that it's a file, again, because it does not have a D as the first character. Okay, okay, so now we know how to create, read, update. Again, we're going to skip. What about delete? If we want to delete a directory, all we have to do is rmdir. Okay, so remove directory, Linux intro. Okay, now if we do this, we'll get an error saying that it's not empty. So this happens because it's a security mechanism of Linux just to prevent you from messing up big time. So instead, what we can do, and to bypass this safety, is use the same remove command, but we can give it a flag that is -r, and this stands for recursive. So recursive means that if you've done any sort of functional programming or just programming with higher order functions or recursive functions, you'll know what this is. But basically, it's just going to go inside the directory and it's going to delete everything inside the directory, and then it's going to delete the directory so that we avoid this error where it says the directory is not empty, so it prevents you from deleting anything. Okay, so same thing, we do remove recursively, so everything inside Linux intro directory. So we do that, and then if we list all of our files again, we see that Linux intro directory is no longer there. Okay, I hope that makes sense. Okay, so one last thing before we move on to a different topic, we're going to talk about how to copy and how to move and rename files in Linux. Okay, so first thing, we have this test.txt, and let's say we want to copy it inside this Linux intro directory. So the way we do that is with the copy command, cp, the name of the file that we want to copy, or in other words, the source, so test.txt, and the destination that we want to copy it to. So in this case, Linux intro. Okay, and so we're going to copy the test.txt file into the directory called Linux intro. So if we run this command, we ls, we see that we still have test.txt, and if we ls inside Linux intro, we see that we also have test.txt inside the Linux intro directory. Okay, that makes sense. Now, what if we want to move a file? Okay, so let's move Linux intro.pem. So right here, inside my current directory, we want to move that as the source into the destination Linux intro directory. Okay, so if we run this command, we see that Linux intro.pem is no longer in my current directory, and if we ls into Linux intro, it's now inside the Linux intro directory. Okay, I hope that makes sense. One last thing, the move command can actually be used to rename files as well. So for example, we have test.txt inside the Linux intro. So what we can do is test.txt inside the Linux intro directory, and we want to rename it. So same directory, because otherwise we would move it, okay, into like test renamed .txt. Perfect. Now if we do this and we ls into Linux intro, we'll see that test.txt has become test renamed.txt. Okay, I hope that all made sense, and let's move on. All right, so if you're paying a little bit of attention, you might have been wondering, how come that we have ls by itself and it prints out my present working directory, pwd, but ls, this one, you can specify it. So how come we don't have to specify anything for the present working directory? You know, like why don't we have to do pwd and then ls and paste this in there, right? Which is exactly the same thing as just doing ls by itself. Well, it turns out that there are special, there's two things happening here. There's default arguments, which are what this is called, is what this is called. These two are arguments, okay? It's like a parameter in a function, okay? But for Linux commands, they're called arguments. So there are default arguments. In the case of ls, the default argument is your present working directory. However, it doesn't look like this. If you do this, it has no idea what you're talking about. So how does Linux do present working directory as the argument for ls? The answer for this is that there's two special characters. There's a dot slash and there's a dot dot slash. Oops, dot slash, okay? So if I do ls dot slash, what happens? Exactly the same thing as ls pwd, but this time Linux knows exactly what I'm talking about, okay? So dot slash, I'm gonna write this out, dot slash equals present working directory, basically, okay? So if you were to have done like the move command, for example, move test.txt into dot slash test.txt, we run this, you'll see they are the same file because it's looking in the same directory, okay? Because this is present working directory slash test.txt. So I hope that makes sense. The other thing is dot dot slash, okay? So if one dot slash is my present working directory, then two dots in a slash is the previous directory or the upwards directory. I don't know how else to call it, so I'm just going to demonstrate. So first, in order to learn and then see this in practice, we're going to learn how to switch directories. Okay, so for this, we use the change directory command, and we're going to change directories into the Linux intro directory that we have made from earlier. Okay, so now you'll see that here it reflects my current directory. Okay, so I was in the test directory before, right here, and now I'm also in the Linux intro. In fact, we can, if we take a look at the pwd back here, we are in /home/rpi server/test. That's why it says /test here. And now we cd'd into Linux intro, so that's why it says /test/Linux intros, okay? Now, if we do ls here, we see the files inside the Linux intro because this is my present working directory. Again, if we do pwd, we are now inside Linux intro, ls this, which is the same as present working directory. It's exactly the same thing, okay? As ls, I mean, okay? because we're now in this directory. Now, if we want to go back out to the previous directory, so by previous, I mean like one above, okay? You do dot dot slash. So cd dot dot slash is for the directory above my current directory. So we were previously in Linux intros, now we are in test because we went one behind. If we do dot dot slash again, we're just going to be inside tilde directory. This is known as the home directory. We're going to get into what this means later. But as you can see, we can move forward and backwards through directories using cd with the name of the directory and dot dot slash to go upwards a directory. So now I can ls see all of my directories, cd into test, ls again in Linux intro. I can also cd more than once. Sorry, I meant to do this, is what I meant. This is getting more complicated now, but don't worry about what I just did. Anyway, here we can list all our directories, and let's say I want to go straight into the Linux test, right? So what we can do is change directories into test, because I know it's there, and then in here we can do Linux intro. Okay, so we can change directories many times in the same command. And now I was in my, previously I was in my home directory, and now I just went into two different directories there. So now I'm inside Linux intro. I hope that made sense. Okay, so next up, I want to give you kind of a fun reason to use Linux, and that's customizability. So unlike Windows and all these other operating systems, you can actually customize your commands exactly how you want them to function. So for example, let's say I'm always running ls and I'm always running ls-l. There's even more flags. For example, you can do ls-lah. We can, I'm going to explain what this means and how you know what flags to use later. But if you run this, we just get different outputs. You'll notice now we have a dot, and we have a k now here. Right? We just have more information, okay? So instead of writing all of this, what we can do is actually set what's called an alias. An alias just means that instead of running ls, we can run my own custom command that I set, and it's going to do the same thing. So for example, I'm going to set an alias, if I can spell, alias test is going to be equal to ls-lah, okay? Enter. So now you can see what this alias is. So by doing alias test, and it says test alias equals exactly what we set. So yeah, if we just run test, we get the same, exactly the same functionality as ls-lah, okay? So you can do lots of cool, fun stuff with this. This is especially useful for longer commands, like if you're working on a specific project and you're always having to build it. Like for example, I know in Python you can use ubicorn. Like anyway, you can make a lot of interesting stuff with aliases. There's also default aliases. For example, I'm pretty sure the majority of Linux distributions come with default alias ll. As you can see, it's ls-lh. There's also alias l, which is the one we just made. So, alias test, right? Exactly the same thing. The order of the flags usually doesn't matter, but there are some cases in which it does. We'll get to that later. So if I just type in L, I will get the same as if I just type in test. Okay, so that's aliases. And so now we're going to talk about how you know what flags and commands do. Okay, so you might be wondering, how do you know what these flags are, how to use these commands? The answer is by using the manual. Okay, of course there's a manual. These people that made Linux are old, so we can use the man command manual and then the name of the command that we're going to run, and it'll show us an example and the usage of the command. So for example, ls is used for list directory contents, and this is how you use it: ls options/flags and then the file. Okay, and here are all the flags. -a, you can scroll down. If it doesn't let you scroll, it's because this is using Vim commands. We'll talk about Vim a little bit later, but on the screen I'll put the Vim commands that you can use. It's down is J, up is K, and then you can quit with Q, okay? You can also search by pressing / and then just searching whatever you want. For example, full time, and then there's full time at the top of my screen, okay? So that's how you learn what commands do. If you're on the Docker container that I provided, man does not work because Docker containers aren't supposed to be like user environments. They're just supposed to run programs, and programs never use man, okay? So what you can do instead is I've installed a nice little handy package. We'll talk about packages later, but I've installed a package called tldr. tldr stands for too long didn't read. So I'm going to show you that now. I'm just going to do docker run. So I'm inside the Docker container now. You can do tldr ls, and it'll actually give you a much more summarized version of the manual version, okay? So for example, list files per one line, one per line, ls-l, or one, sorry, list all files, including hidden files, ls-a, that's what we were doing. List all files in long format, which means that you have permissions, ownership, size, modification date, LA, okay? And you can keep going. So you can actually install this, if you're not running on a Docker container, you can install this by, actually, we'll get to that later, but you can install TLDR as well. For now, you can use man. If you don't want to use either of those, the manual pages are actually found at man Linux, I don't know, ls. I can't spell, but you know what I'm trying to do. Exactly the same content is found on the internet, so if you have neither man nor TLDR, TLDR, sorry, you can just use the internet. Okay, I hope that made sense. Okay, so now let's talk about file permissions and scripts. Now, if we run the ls/lah or L in general, we'll see this right here. And by the way, in the future, I'm just going to do LL, which is exactly the same thing. As you can see, it has the same things. We can check this by doing alias LL, but I just prefer doing this because it's faster. So we're using aliases, okay? So if we do ls/lah, we can see this section here. And this looks really scary, but I'm going to put an image on the screen right now that describes what it is. These are access permissions, okay? All it means is that it's broken down into 3 sections, and it describes who, so which user or which group or who in general can access, so read, write, or execute these files. Okay, and it's actually in that order. So R is for read, W is for write, and X is for execute. It's not here because none of these have execute permissions. Okay, so the first group of 3. Okay, so first we know that the first one is used to determine the type of file. So if it's a file, if it's a directory, if it's whatever. Okay. The next group of 3 are read, write, execute permissions for the owner of the file. The owner is going to be the first username that shows up here. All right. So this is the permissions for our Pi server, which is the owner. The next 3, which here there are none, so it's not a great example, but let's use this one down here. The next 3 are the permissions for the group of the owner. So here's the owner, iPi server, and the group that our Pi server belongs to is our Pi server as well. So whichever user is in the group called our Pi server is also going to have these permissions. We're not really going to focus on groups because it's kind of hard to demonstrate and it's kind of out of scope of this intro. Okay, but the last one is kind of important, and that's everybody else. So every other user that is not the owner and is not in this group is going to be a part of these 3 permissions. So in this example, what does this say? This means that the owner, which is our Pi server, has read and write permissions but cannot execute this file. Okay, and I'm gonna prove that right now. Again, we're gonna skip the middle because it's out of scope. And then this last part, anybody else that is not the owner and is not in the owner group is just going to have read access. They're not going to have write access or execute access. Okay. And again, this first one just means the type of file. So in this case, it's a file because it doesn't have a D. If it has a D, it's a directory. So how do we run a file? How do we execute a file? This we're going to get into a lot more detail later, but everything in Linux is a file. ls is actually a file that exists in your machine. Same with cat and a few other commands that we've seen like head and tail. These are all actual files that live inside your machine, and we can check where they live by using a specific command, but we're going to get there later. As I said, there's going to be a whole like operating system part of this video. But anyway, the way we execute scripts or the way we execute a file is by doing // So again, this just means current directory and the name of the file. So test renamed in this example, renamed txt. Permission denied. Why? Because the owner only has read, write, but no execution privileges on this file. So we're never going to be able to run this. Okay. The only person, or there's 2 ways that we can run this file at this point. Number 1, be a super user. Super user is like the owner of everything. They have access to everything. It's like being a system admin, basically. And the way we can engage or act as a super user is by using the sudo command. So sudo just stands for super user do. And now if we do test renamed .txt, it says command not found this time. So we have permissions, but now it doesn't know what we're talking about. Obviously, because there's number 1, there's nothing in the file, and number 2, it's a .txt. So we'll make a script in a second, but I just want you to know that permission is granted because we're using super user, but the command is not found. Now you might be wondering, why not just use super or sudo for everything? And the reason is because it's dangerous. If you have access to everything, it means that you can rm or delete literally everything off of your device. Okay. If you try to remove things from your device outside of your home directory, so outside of tilde, then you're going to need super user privileges. And if you don't have that, it'll give you a permission denied error, which means that you can save yourself from a massive problem. Okay. So typically you don't want to use sudo unless you know what you're doing. Also, specific users might not even have access to sudo. When you connect to a remote server, which I'll also show you how to do very soon, you might not have access to sudo because they don't want you to do anything that's risky. Okay? Your company might not want you to delete random files. Okay, so that's why sudo exists, and that's why you might not have access to it. In this case, we have access to it because the root user, or like the only user, can have access to sudo, or at least that's the way that I've set it up inside the container and inside my server here. Okay. All right, so we tried bypassing the permissions with sudo, but what if we don't have sudo access, or what if we just want to give access to everybody else and they don't have sudo access? So the way we can do this is by just changing the permissions, adding or removing permissions from this list. So the way we do that is with the chmod command, or change file modification, change file access modifiers is what it is. So you do change file modification command, and then you can change for a specific user. So as I said, the first three are for the owner. The owner is the user. Okay, so we can do u, and we're going to add the execute permission on the file called test rename. So if we do this and we do ll, you'll now see that only the user has received the execution permissions on this file. Okay, and the file turned green because now it's a script that we can run. Okay, but we can do the same thing with groups. Okay, so if we do the same thing and we do ll, now groups also has the X permission, and we can do the same thing with the last group, or the last section here, which is other, or O. So if we do ll again, we see that everybody now has execute permissions, and we can do the same thing for like read or write, right? We can also remove permissions. So other is now going to be removed, is not going to have execution permissions. So if we do this, we'll see that X was removed from the others because we have a subtract sign here now. Okay? We can also remove from everybody at once by using A. So change mod AX. So now everybody loses their permissions. There's also another way to use the change mod command, and that is by using numbers. And this is not going to make sense for you at the moment, but you can search up how to use the change mod command. And I'm going to show you this right now by actually running this. Never do 777, by the way. That's horrible. But you can do, what you can do, sorry, is like 511. So super brief. The 1 is for execute, or execute has a value of 1, read has a value of 2, and write has a value of 2, and read has a value of 4. So if we do 5, that means that we have read, which is 4, plus execute, which is 1. So read and execute privileges are going to be assigned to the owner. Next, the group is going to be assigned the execute privileges, and then everybody else is also going to be assigned execute privileges. So if we do this, we'll see exactly what I said. And you don't have to learn this right now, but just know that it exists. And this is great for setting like all of these permissions exactly as you want in one command. Okay, so now let's make a script. Okay, so to make a script, what I want to make is just something simple. We're going to count the number of files that we have in the current directory. Okay, so right now we know that there's 2, but if we start making a whole bunch of files, like for example, touch test1 and touch, test2, so you can actually make multiple files like this, test3, and then we ll, we now have all of these. Okay, 1, 2, 3. So if you can imagine, if you have like a ton of files, this gets crazy. So we want to count the number of files that we have in our current directory. So the way we're going to do that is we're going to make a script. The command that we're going to use for this is actually called WC, or word count. Specifically, we can count the number of lines using word count -L for lines, or characters with -C. You can do the tldr on word count to see exactly what it does. But if we try to do word count like -LLS, this doesn't work because the way you use this command is that you give it a file or some sort of input. Okay, so this doesn't work because we need ls to run first, right? So we need to ll and then count the number of lines. So we need something like ll and then do the wc-l using the output of ll. You see what I'm trying to say here? So this is going to run, and then we're going to take the input, or sorry, the output of that command and give it to wc-l. Obviously, this doesn't work. This isn't actual Linux, but we can replace with then with a pipe. This is called a pipe in Linux. This is a character on top of your enter. Probably, I don't know what keyword you're using, but you can search up pipe in whatever keyboard you have, and that's exactly what it is. So just like I explained, we're going to take the output of this command and put it as the argument of the following command. This is exactly what it does. So if we run this, we get 6 lines, and that comes from 1, 2, 3, 4, 5, 6. Okay, this is called piping, and this is extremely useful in Linux. Yeah, so that's piping. So now we're going to use this command and put it inside a script so we can run it. So what we're going to do is we're going to first make a script. Now, to do this, do not follow along because you need to know Vim. Okay, so you know about IDEs, right? So there are IDEs like VS Code, IntelliJ, all these sorts of different things. They're basically just coding environments where you can, a special text editor for code, right? However, as you can see, there is no UI in terminals. Like you cannot click buttons. So instead, what exists is a default editor that's called VI, and you're guaranteed that VI or some flavor of VI, like VIM or NeoVim, so NVim, is guaranteed to exist inside a Linux distribution or environment. So we're going to use Vim, and we're going to call the file like mytest.sh. .sh means shell. Okay? So typically you call your scripts .sh, so you know that it's a script. We'll talk about the shell some other time maybe. And the way that you tell a script that it is a script is by doing this format. So you don't have to learn this, but I just want to show you what a script looks like. Okay? In a script, we just use normal Linux commands, but we just put them in a file. So we're going to do exactly the same thing. We're going to do a ll, which is what we did. We take the output of ll and we're going to pass it in as the argument of the following command, which is count the number of lines. Okay, that's literally all we're going to do. We're going to save that. Again, don't do what I just did if you don't know Vim. And now we're going to try running this command. So we see mytest.sh. So let's try running it. Again, we run a script by doing // and then mytest.sh. Permission denied. Again, why? Because the owner of the file, which again, rpy server, and as you can see here, I am rpy server. Like that is my user right now is rpy server. The owner does not have execute command. So again, we're going to do a change mod user. We're adding the execute privilege, or yeah, privilege, whatever, into my test script. So we do this. Oops. And now we have my test, which has execute privileges or permissions. So now if we do this, my test, command not found. Wonderful. Okay, so it looks like the alias isn't working. So let me quickly fix this. The reason is because we're not running the same command. It'd be like this. Okay, so now if we run my test like this, and we do ll wc-l, we get the same output, okay? And we can see what's inside my test.sh, and you see all we're doing is we're declaring that it's a script, and we're running the ls-lh command, so ls-lh, and then we're doing wc-l, and we get exactly the same output, okay? So those are scripts, those are permissions, and how to change them. All right, so now let's learn about iostreams. Iostreams sounds like a complicated thing, but in reality, it's a little bit simple. It's not super simple, but it's whatever. So when we write something to the terminal, how is this being sent to the kernel? So what's happening is that the terminal is actually a UI for something called the shell, and the shell is actually the one talking to the kernel. So earlier I just made a simplification, but now that we know more, we can learn more about this stuff. So how does the shell know what to read from the terminal? Because obviously when we run this isn't like an API call or anything. The shell is just like listening at all times. So how this is happening is that when we send a command, it's being put into a buffer or a stream, however you want to call it. That's called a standard input, or std in, like this, okay? Likewise, when we do a command and we get a response like this, a result, this is called std out, standard output, okay? There's also another thing called standard error, std or err. So whenever you get an error like permission denied or something like this, that is standard error, okay? So standard error and standard out are both read to the terminal because they're hooked up like that. They're constantly listening to each other. So the reason I'm telling you this is because we can actually redirect contents going to the standard out or standard in or standard error even to files or to each other. So let me explain. There's a thing called a redirection operator, and they're simply just a greater than or less than sign, less than greater than sign, and all it looks like is like this. So for example, we're going to ls, and we're going to greater than into just a file. So for example, output.txt. What is happening here? So we're going to take the output of ls, which is going to end up on standard output or std out, and we're going to redirect std out into a file called output.txt. So if we run this and then we see what's inside output.txt, we actually get the same output that we would get from ls, okay? So again, we're taking the output of ls and we're redirecting it from standard output into output.txt. And we can do this with any files and anything, okay? This one looks a little weird because ls actually puts in, ls is weird, okay? But for example, we can do, let's see what we have in here. What can we work with? Linux intro.pem, mytest.sh, okay? So why don't we actually make a new file? Let's remove test anything, okay? And okay, this is using something called regex or regex. We don't have to learn about that now, but you can do that. It's also very dangerous, so don't try to do this if you don't know what you're doing. But anyway, so let's make a new file. Let's touch something, okay, .txt. We already know how to do this. We have something.txt, but now let's actually add something to the file without using vim. So we can do echo command. Echo is just printing something to standard out. So for example, hello world. Okay, so we get echo hello world, and it just prints out hello world. But again, this is printing out to standard out, so we can redirect the standard out into the file, so something.txt. And now if we cat something.txt, we see hello world. Okay, so this is pretty cool. Now let's echo something else into the same file. So for example, hello I love Linux, echo I love Linux, sorry, into something.txt. Now if we cat, what happens? Are we going to get hello world and then in another line I love Linux? The answer is no. We actually just get I love Linux, because when you do this, when you do the redirection, it's going to replace everything that was already in the file. The way we append is by using two of these. So for example, hello world again. And now if we do the cat, we have 2 lines. So we appended to the end, and this means append to the end of something.txt. Okay. So now that we know all this, we should know enough to kind of go crazy and put everything together. Okay. So as an example, let's do ls, and we can use sort. Let me show you tldr sort. Oh, I actually don't have tldr. That's awkward. But we can do man sort. So sort lines of text files, and basically it's just going to do alphabetical order by default. Just trust me on this. So if we do ls and we want them in alphabetical order, we can just pipe that into sort. So again, we're taking the std out of ls and we're putting it as the argument of sort. And now we get this in alphabetical order. Okay, and we can do this, and then we can put this in a file called something.txt. And again, we're going to again, what's happening here is that this this is the std out of this command, and then we're going to redirect the std out into this file. Okay, so now if we cast something.txt, we have exactly the same information. So this is extremely useful for logs and logging. Okay, so I'll actually show you an example of that with an actual web server in this video. But yeah, so this is kind of how you can mix things, and you can keep going. You can do like, okay, we're going to sort it, and then we're going to put that into word count, counting the number of lines. And then if we do the cat something, now we have 4 lines, and that's 1, 2, 3, 4. And we can put this exact command into a script directly by running the echo command. So we can do echo exactly what we have here, just like this. And we want to put that inside, I think it's called test, no? Yeah, my test.sh. Perfect. Okay, so we do that, and now we can cat my test.sh. And there's the command. I think this should run without the bin bash as well, but that's kind of cheating. We can check to see if we can run it. Okay, we can run it, and now if we check, actually, hold on, we can echo like 10, oops, 10 into something.txt. Oops, that's my bad. There we go. So now let's check something.txt. We have 10, and now if we run the command and we cat something.txt again, we have 5. And again, that's because the command that we ran is doing this, and if we run this, we get 5. I hope you see how this can get pretty useful, and also pretty crazy, pretty complex. One last thing I think we have to learn for sure is grep. Now, grep is kind of like everybody's favorite command, and the reason for that is because it's extremely useful. So let me explain. For example, we can cd out of here, cd slash, let's see what we have in here. Docker file. All right, let's take a look at our Docker file. And let's say we want to find what version of Ubuntu we're running. I happen to know that it's on the first line, but you might do like, okay, Control F or Command F and do like version. Okay, that doesn't work. What about Ubuntu? Okay, there it is, Ubuntu, and then the version is 22.04. So what we did basically is we search for the term, and then we want to get the entire line where the term appears. Okay, so for example, we want to see this make dir command. So make dir, there it is. We have 2 of them. Let's see what it does, and then we read the entire line. This is exactly what the grep command does. So we can do grep make dir, and then the name of the file, so Docker file. And then this is going to return exactly what we just did. So, but in the standard out, std out. So this is extremely useful. So again, I'm going to show you more examples of grep later, but this is super powerful because now from here we can do other crazy stuff. Like for example, we can word count again. I keep using word count because that's kind of all we can do right now. Because we don't know more commands, and there's also not a big enough file for this to be useful, but we'll see what that looks like later. But yeah, that's grep. Now, I think we're good to move on to the networking part. This is where things get actually like applicable. So get ready. Get ready. I'm going to do my best.